The advanced statistics question says, if there is no seasonal effect on human births, we would expect equal numbers of children to be born in each season, winter, spring, summer, and fall. A student takes a census of her statistics class and finds that of the 120 students in the class, 25 are born in winter, 35 in spring, 32 in summer, and 28 in fall. She wonders if the excess in the spring is an indication that births are not uniform throughout the year. A wants us to find what are the null and alternative hypotheses associated with the question. Well, the null hypothesis, or the HO, is going to be slightly different from what we're used to because this is a chi-square test. The HO is that there is no association between the two things in the problem, which in this case are between birth and season. And the alternative would be that there is an association between birth and season. Part B wants us to compute the x squared statistic. Well, for this, we're going to use the x squared function in our calculator. First, we need to input everything into our matrix. So we're going to go to second x minus 1 because this is where our matrix is found. And A, we're going to go over to edit, go to A. These are going to be our actual values. And we've determined it's a 1 by 4 table. 1, which is the number of students across, and each season. And we've already inputted our values, 25, 35, 32, and 28. We're going to go to the matrix again, go to edit, and we want to edit B. These are going to be our expected values. So out of 120, we expect each of them to be 30, because 1 times 4 is 30. So we have 30, enter, 30, enter, 30, enter, 30, enter. Those are our expected values. Okay? Then, to find the x squared, we're going to go to stat. We're going to go to test, since it's a test, and go down to x squared test. We have our observed A, expected B, calculate. Oh no. Now we're going to try something else. We're going to go to stat, edit. Okay, in list 1, we're going to put our actual values. 25, 35, 32, and 28. And then list 2, we have our expected. 30, 30, 30, 30. List 3, to find this, we use the equation to find our x squared statistic. Our equation was that x squared equals observed minus expected squared over expected. Our calculator, the reason how we did this in our calculator was we took L1 minus L2 squared over L2. Then it gave us all our values for L3. X squared is the sum of all these values. So if we add 0.8333, 0.833, 0.133, and 0.133 all together, you get x squared equals 1.9332. Using the back of our textbook, we determined that we have, this is our x squared. So we answered part B. Now part C wants us to answer, how many degrees of freedom does the x squared have? Well, we have 4 seasons. And degrees of freedom equals n minus 1. So n was 4 minus 1 equals 3. So we have 3 degrees of freedom. And what can we conclude about the null hypothesis at alpha equals 0.05? Well, with an x squared of 1.93332, we can use a table in our textbook to determine that p is greater than 0.25, which is a very high b value. And we've determined that an alpha of 0.05, we fail to reject the hoe, that there is no association. And there might be an association, but we just fail to reject that there isn't one.